Welcome back to example 3 in our notes for graphing exponential functions. And in example 2 and the one after, we looked at how to graph exponential growth. The process is exactly the same for exponential decay. The only change is that our parent function has a base that is between 0 and 1 non-inclusive. So the parent function equation here is y equals 1/2 to the x power. And that makes it exponential decay. Decay means that the graph is going to start very steep and then it's going to flatten out when it reaches that bend in the J shape. So the horizontal asymptote is still the k value. When we label each of those from transformation form, our a is the multiplier out front of the base, so that's a -8. The b is the base, and our base is a 1/2. The h is up here with the x, so x minus h means our h is a +2, and then the k is the constant on the end, and that's a +5. So my horizontal asymptote comes from the k value, so y equals +5 is my horizontal asymptote, and I can come over and sketch that on the coordinate plane for the graph of my exponential function. Okay, next we're going to identify the anchor points of the parent graph, 1/2 to the power of x. 0, 1 is always the y-intercept on a parent graph. Then 1, b, and our b is 1/2. And then -1, the reciprocal of b, and the reciprocal of 1/2 is a +2. Okay, next we're going to multiply each of those y values by the a, and the a is a -8. So the x stays the same, and then 1 times -8 is -8. Okay, the x stays the same, and 1/2 times -8 is -4. And then the a stays the same, and 2 times -8 is a -16. Okay, next we want to add the h, and our h is 2, to each of these x coordinates. So 0 plus 2 is 2, and then the y stays the same. 1 plus 2 is 3, and the y coordinate stays the same. Then -1 plus 2 is a +1, and our y coordinate stays the same. And then we have to add k, which is 5, to each of these y values. So the x stays the same now, and -8 plus 5 is a -3. Then the x stays the same, and -4 plus 5 is a +1. And then our x stays the same, and -16 plus 5 is a -11. So we'll come over to the graph of our function and plot these points 2, -3, and then 3, +1, and 1 all the way down here to -11. Okay, now we're going to need another guide point to see how fast we bend here to approach that horizontal asymptote. So we have values for 1, 2, and 3. Let's go ahead and put in a 4 for the x. And so I'm going to grab my calculator here, and we'll look at how to enter that in the calculator. There we go. Okay, so in the home screen here, we can store our x value So for store x, enter. And then I can type my exponential function just like I see it. So -8 parentheses 1/2, close the parentheses, then exponent key, and this exponent is a quantity grouped together, so we're going to need parentheses around that exponent, x minus 2. Okay, you must have those parentheses there, and then outside of the exponent now we have our k, which is +5, and we press enter and we get back a 3. So the point 4, 3 is on the graph. Okay, if I want another extra guide point here, I can store my next integer 5 as the x, then arrow, or second enter, I guess will get us there, second enter, yep, retypes my last statement, and then I get a 4, so the point 5, 4 would be on the graph, and we can see now how that bend is starting to emerge. You can repeat that as often as you like. If you wanted to find another guide point at 6, then second enter, and we get 4.5, right? So now we're making a real sharp turn here towards that horizontal asymptote. So as we come along these anchor points and then bend, and we approach but don't cross that horizontal asymptote. And the domain is fully unbounded, interval -infinity to +infinity. The range, because there's been a reflection in the x-axis, we're starting at -infinity and then approaching that value of k, which is 5. And that brings us to the secret question for this lesson on graphing exponential functions. And you're going to need some scratch paper to work this problem out. Your function is y equals 4 times 1/2 raised to the x minus 1 power plus 1. You're going to identify the parent function, determine if it's growth or decay, identify the horizontal asymptote, then do the transformations on the anchor points, plot those points along with an extra guide point where x is 3. Then once you've graphed it, you'll identify the domain and the range. So in addition to uploading this as your last page to your notes in Schoology, this time I also created a short assignment in Schoology for the secret question so that you can get some immediate feedback faster than I'm able to keep up with grading them one by one and typing in the feedback. So when you're prompted, you'll put in all of your answers to the secret question as you work through it, and then when you hit submit, then the computer can auto score it and you'll know right away if you're getting the hang of it or not, and can ask questions from there if you need some extra support.